Welcome back to iGen Politics. This is a podcast that makes politics engaging and relevant for all generations. This is Victor Shi. I'm currently a sophomore at UCLA, was elected as the youngest delegate for Joe Biden, and also co-host this podcast.
And I'm Jill Wine-Banks, the author of The Watergate Girl, and an MSNBC legal analyst, and the wearer of hashtag Jill's Pins. And today's pins, and I'm wearing two separate ones, are a moon and stars. And that's because our guest today is none other than Neil deGrasse Tyson.
As Jill said, today we welcome back Neil deGrasse Tyson. He was a guest last year and fascinated us and our audience, talking about some of the biggest questions of our universe, that we couldn't wait to have him back again, and thought that the recent republication of his book with two co-authors, Welcome to the Universe, in a 3D format was a great time to do it, so here we are. We will include that last episode about cosmic queries in our show notes. Welcome to the Universe in 3D, a visual tour, takes readers on a grand tour of the observable universe, guiding us through the most spectacular sights in the cosmos, presenting a rich array of stereoscopic color images which can be viewed in breathtaking 3D using a special stereo viewer that folds easily out of the cover of the book and reveals our cosmic environment as we've never seen it before.
And Victor, why don't you hold it up and show what it looks like to look through the 3D viewers? It's like going to the movies, except in a book.
Yeah. So this is an episode that you would want to watch on YouTube if you can, but if you can't watch it, it's a cover that looks like this. It looks like the cosmos, and then there's a flap at the back of the book, and you peer through it, and you look like you're a yellow person looking at 3D images. It's a really fun book.
So in the unlikely event that there is anyone listening or watching who doesn't know Neil, let me give you a brief summary. He is one of the most famous and influential astrophysicists to ever live. He is currently the director of the Hayden Planetarium at the New York American Museum of Natural History, and a prolific author, having written numerous books that aim to make science more accessible and understandable to everyone. He is also the host of the podcast Star Talk and hosted 2 seasons of Cosmos, televised by Fox and National Geographic. Neil has received 21 honorary doctorates and NASA's Distinguished Public Service Medal. We are delighted to have Neil with us again today, and thank you, Neil, very much for being with us.
So thanks for having me. Thank you.
Of course, we are so excited, and your new book is in such a cool format and reminds me of really every reason why I love science. Reading about the concepts and then interacting with the images made this book a unique experience, and it made me feel like I was traveling through the universe. So I'm wondering...
Did the publisher pay you to give that commercial? That was like
it's
a
amazing.
Scripted commercial.
Neil, like I was reading through this book, and you do this like this, and
yeah, you do.
It's amazing.
It's got a viewer lens thing.
Yes,
thingy.
yeah.
And yeah, it's pairs of photos, and it feels kind of retro, right? Because we all have such high profile, very expensive, Oculus, Google glasses, goggles, high res. You have all of this, and okay, I get that. But when you have carefully chosen pairs of cosmic imagery, carefully chosen to be able to be seen through these, I'm going to call them binoculars, through these. The viewer, the object transforms in that moment from a picture of the thing to the thing itself. The moon goes from a picture of the moon to an orb, a place that you might visit. And this shift, I think, affects you emotionally, especially since on the website, welcometotheuniverse.net, it was a last minute, like in the last 2 weeks, we said, why don't I narrate the captions? And so if you have the book, you click on my narration of them, because that way you don't have to read them and then look through it. You can hear, and I put on my best planetarium voice, of course. And now, welcome to the universe. So I narrate each of those images while you're looking at them, just to add a little sort of in the moment emotion to what it is you're experiencing. And yes, the book is a very different format because of this. The fold-out viewer, yes.
And so this isn't actually the first, I guess, version of this book. when did you first write Welcome to the Universe? And I guess for this version, who did the graphics for this? Because it's amazing.
Yeah. So let's back up. So I spent a while on the teaching faculty at Princeton University, and I co-taught a class, an intro to astrophysics class, with two colleagues. We sort of invented this class. And initially it had like 40 people in it, and then it had 100, and then 150, and then 300. We had to keep changing rooms, and we realized why people enjoyed the class. Because the three of us were kind of storytellers, and so it's not just the science and the bold-faced word that you have to memorize for the exam. It's a science as a process, science as an avocation, science as a love. And so after a while, after we did the course and it was transcribed, they said, why don't we turn this into a textbook? But it's not really a textbook because there's a lot of storytelling, and science textbooks don't have storytelling in them. And so we wanted to stay true to the course, literal and figurative, stay true to the course, and we did. And then there were other colleagues that said, we want to use this as a textbook, but it doesn't have problem sets in it. We said, okay. So we wrote a whole problem book to go with this pseudo textbook, right? Because it's really, let's embrace the universe for all its glory is really what that book is. So we created a problem book to go with it. So now you can use the two as a textbook if you want to teach introductory astrophysics. Then people said, we love this so much, can you make a more portable version? So we said, sure. It's easy to make something big little. You just sort of hack away at it and make it smooth. And so we made Welcome to the Universe, the pocket edition, and it fits in your jacket pocket, okay? You can take this wherever you're going and catch up on the latest, cool things in the universe. And then we said the universe is visual. So we can't just have stuff to read, we want stuff to look at. And so then came the idea that we have this run of images. And these images, many of them come from the collection of our fourth author who we accreted for this book. His name is Bob Vanderbay. Big time astrophotographer. Oh man. By the way, the moon only shows one face to Earth, but if you looked at it carefully, it jiggles left and right, just a little bit. And so what he did was he took a photo of it jiggling one side towards us, waited until it jiggled the other side towards us, and used those two as the stereo image. And it was brilliant because now you're like looking around the sides that you want to like hug the moon as it shows up, as it pops in these visuals. And it's true for all the objects in there, especially the constellations, which spread out in space, because so many people think the constellations are real things in the night sky. No, they're stars scattered across the galaxy. And they sort of, you stay on Earth, and you say, oh, this is what they look like from Earth, but what do they look like a little bit to the left and a little bit to the right? They don't look like what they look like from Earth, because they're not anything at all. And so this is a revelation to some people, but this book also takes you there. So it's quite the exploration. We're all very proud of it.
Well, we certainly want to get into the content of the book, but let's stay with photographs for a while, because one of our producers has come up with some photographs of you in college as a dancer.
What?
Those are in
3D?
black and white, I think. So. You want to talk about your think from that era?
I don't, it's just something I did. I don't,
But,
I was a performing member of 3 different dance companies in college and in graduate school. And I probably should have spent more time in the lab, while I was doing that. But I was in excellent shape, physical shape. I mean, I used to also wrestle. I was an undefeated wrestler in high school, not so much in college. I was very defeated in college until my senior year. But the point is, as a wrestler, I was strong and limber, but there's no requirement that you be graceful. Whereas as a dancer, you have to be strong, limber, and flexible, what I mean by limber, and graceful. And so that extra dimension, that extra combination, it changes you. It changes how you walk, how you run, how you move, how you sit, how you stand. It's a general, total awareness of what all your muscles are doing at all times. And good dancers do this, and they because they control their body, every muscle of their
Dancing
body.
is fabulous.
And there are dance exercises where you isolate just one part of your body, your shoulder, your elbow, your rib cage, your diaphragm, your calf, the back of your leg, the front of your leg. And once you do this, you have a whole other sensory awareness of what your body is and what it can do. And I can tell you, because this has never really come up, because no one else has dug up photos of me dancing, is when I give public talks, people say, well, here's your podium. So you're going to stay behind the podium? No, I'm going to walk on the stage. It's a stage here. All right. And I find myself gesturing with my body when I'm talking about how bulbous the sun will be, when it becomes a red giant, or when there's an explosion. I find myself imitating an explosion, almost unthinkingly, because I'm communicating not only with words, but with every tool I have available to me. It's facial expression, it's body posture, body gestures. So I thank my time as a dancer for even thinking to do that, or doing it so instinctively that I don't think to do it. It just happens. And so for me, the stage is the full place where I teach you what goes on in the universe.
It's like when football players do ballet. I just thought of that. I'm like,
Well,
they have to be graceful.
Yeah, that helps them out. That'll help them dance
yeah.
around. And you see they're like gazelles on the field. I was once at the training center for the Seattle Seahawks. And that's done in the dome so that you can't film their secret plays that they're planning. So I'm in the dome, and I'm watching a big, one of these air domes, but there's an entire football field in the dome. And just to watch the quarterback throw and watch the pass receivers run, they're like gazelles, and then they catch it and they keep running. And I was like, oh my gosh. So yeah, it's another form of ballet, really. You don't think about it because a play ends when everyone is tackled on the ground, but before they're tackled, everybody's a ballet dancer on the field.
Well, we're going to post in our show notes those photographs of you as a college dancer. And if you want to give us
And you got
your
these, how did you get them?
We got them through one of our producers has a friend who was a classmate of yours at UT. That's how we got them.
Oh, okay.
And if you want to provide the high school wrestling pictures, we'll put those up too. I would love to see those.
No, back then, nobody carried around cameras with them. Your cell phone didn't have a camera because you didn't have a cell phone. Your cell phones weren't invented yet.
Yeah.
So much happened in people's lives that just went unrecorded. And that, I don't know that we have video of me dancing. I bet that doesn't exist at all.
I bet not. And this is something Victor will never understand because he grew up in the era when there was always a cell phone, and he can't imagine not having a picture of what he ate.
Yeah, you were a highly documented generation.
Yeah, exactly.
Right. For us, it was special
Always
occasions.
have our phones.
But so, anyway, back to the content of your book. I want to read the first words of your book are, go out and simply look up at the night sky. Everything from the moon to the planets and stars to the band of the Milky Way appears to be pasted on a two-dimensional surface, the dome of the sky. Yet over time, humans looking up at the sky, just like you, discovered something fundamental. And so first I want to ask you, what is that fundamental thing that humans discovered looking up?
Well, there's a lot of fundamental things, which include realizing that the universe is not lights embedded on the inside of a dome over your head. All right, you go back to the ancients, they knew the planets had to be sort of closer than that because they moved, and some planets move faster than others. Mercury moved the fastest, and that object they named for their god Mercury, the messenger god. So there's all this correspondence with the Roman names for the planets and the personalities or the other features otherwise represented by the gods. Mars is red, so it was given to the god of war because war generally leads to bloodshed, and blood is red, right? So you get all of this, but then what happened beyond the last planet? Saturn was the last planet to the ancients. And there must be a big gap, and then you get to the stars. And all the stars are on this inside of a dome. And if that's the case, then the patterns the stars make, you would think they're real. The gods put them that way. Oh, there's a centaur and a crab and a lyre, a harp, and this and a that. You just go on, and you pick all the stuff in your culture and say the gods must have put them there because this is what they look like. Fact is, they don't really look like that. It's like drug-induced help. Sleepless ancients looking up with really striking imaginations, coming up with all the things they claim are on the sky. Fine, there's like 3 constellations that look like what they're supposed to be. The rest require extraordinary imagination to make them happen. But they're not thinking that way. They're thinking this is a gift to them because you're in the center of the universe and everything revolves around you. What was the profound discovery? Everything doesn't revolve around you. No. And things don't even revolve around the sun. The planets do, but not the rest of the stars. Oh my gosh. The three-dimensionality of the universe blew open anybody's understanding or belief system that somehow all of this was put in the sky for us. And so this book is a celebration of realizing how much of the universe lives in a full 3 dimensions that forces you to think differently about what our place is within it.
So listening to you, I'm wondering, with your expertise and knowledge and having actually looked through telescopes to see these things, what do you see when you look up? It must be different than what I see.
Well, I have extra knowledge I can attach to it, but the first pass is just the beauty and the splendor. Even to seasoned astrophysicists who've been to the telescopes 1,000 times, will always pause to take a peek at Saturn through a backyard telescope, just because of how strikingly beautiful it is. Wow. And from there, you say, oh, it's got a ring system and moons and Titan and this sort of thing. We can go there. Yeah, I can take you there. And that adds to the appreciation of it. But that first level encounter, one never grows tired of that.
Well, reading your book and knowing that we would be talking inspired me to sign up for an astronomy event at Northwestern a Friday, tomorrow. And it includes meeting with astronomers, and they're going to let us look through the special telescopes at Northwestern. And I've never done anything like this. I've been to the
All you got to do is ask an astronomer about their telescope, then
planetarium.
The next 3 hours of your life are occupied by that conversation.
Okay, that was one of my questions, was what should I ask? What should I expect?
You don't have to. It is so rich in curiosity and fulfillment of curiosity when you are by the way, you have to make sure it's not cloudy that night. Okay, so check your weather forecast. And they surely have a backup date for it. By the way, it's not a rain date, it's a cloud date. All right? Wherever there's rain, there's clouds, but even if there's no rain, you can still have clouds. And that'll knock out the star party. But the questions will descend upon you like manna from heaven. You'll say, oh my gosh, look at that. Tell me about this. Tell me about that. You don't have to preload your questions. They will fall from the sky.
So I'm in Los Angeles right now, and a few minutes away from 30 minutes away from campus is the Griffith Observatory, and we went there on a cloudy day. My only regret is that we went 10 minutes before the observatory actually closed, but you look through the telescope and it was...
You went there on a cloudy day 10 minutes before they closed?
It was not a great idea. We went back and we went on a clearer day, and it was so striking just seeing the night sky. I'm totally with you. You just are amazed and fascinated.
It's not just the night sky itself. The objects on the sky that are worthy of pointing a telescope at. There are a lot of stars that are just slightly brighter dots of light when you look at them with a telescope. But you need to, with a good experienced observer with you, you'll be able to see all the other objects that lend themselves to beautiful telescopic views.
It was amazing.
And while we're talking about looking up, of course, there is the movie Don't Look Up, and I'm assuming you saw that. And does it in any way resemble what is possible or real, and the danger of this?
Society or the universe?
Both, I guess, but particularly of our being destroyed
Yes.
by a collision.
Yes, there are comet collisions. They're in the fossil record. We have the cratering record on Earth. Just take a look at the moon if you want to get a sense of how often Earth is hit. Earth has an excellent way of burying the evidence, or making the evidence go away with erosion and plate tectonics and this sort of thing. The moon has no such mechanisms. So the cratered surface of the moon is what Earth would look like if we didn't have weathering, plate tectonics, or an atmosphere. The atmosphere protects us. The plate tectonics hides the evidence. So in that film, I'm watching it, and everything I know about social media and how it interacts with information, the newscasters, the gossip chain, the celebrity mill, all of this, everything I know about those sectors in modern society told me 2/3 of the way through that film that it was a documentary. That's just
Oh, dear.
documentary. That's what it is. That's what it was.
Okay.
Wow.
And so going back to astronomers, what kind of things are astronomers looking to find now? What discoveries do you foresee? Or, I mean, of course, hard to
So just 2 days ago,
foresee a discovery, but
just 2 days ago,
what are they looking?
there was the press conference for the Decadal Survey of Planetary Science. Decadal Survey. So my people, my whole community, the astrophysics community, every decade, we send our most trusted representatives usually to Washington, because it's run by the National Academy of Sciences, and they lock themselves in a room and prioritize the next decade of spending of money in science projects. And there's subcommittees that plug into that. Until 3 decades ago, all space science was covered by this. But then when we learned we could send probes to planetary surfaces, the planet people were no longer astronomers, really. They were like laboratory scientists, because they could send a probe. I can't do that with a black hole or a galaxy or the edge of the universe. If you could send probes and bring back samples, that's a whole other kind of way of doing science. So the planetary scientists speciated off, and now they have their own decadal survey. So 2 days ago was the press conference for the decadal survey, and there are mission plans in there to go land on Enceladus, one of the moons of Saturn. And Enceladus has geysers, ice geysers, from a liquid ocean beneath a layer of ice. So you don't even have to melt through the ice. Just wait for the water to come to you as it geysers up in the crevasses of the frozen surface. So there are plans to go to visit Saturn for that purpose, to land on Enceladus, to see if there's any microbial signatures of life in what geysered up and I was going to say rained back down, snowflaked back down to the surface. There are plans to go to Uranus and study Uranus the way Cassini studied Saturn. Uranus has a ring. It's a perfectly normal looking system, except its axis is tipped 98 degrees from the vertical. Like, who ordered that? When did that happen? What? How did it survive that? Was that in the early solar system? Is that common? We don't know. So many unanswered questions. We want to have a lander on Mercury. We've never landed on Mercury before. That's an interesting hunk of rock where most of its mass, has the largest fraction of its mass in the form of iron. It's got a huge iron core relative to the rest of it. So Mercury would make a really excellent paperweight if you could. So
if you had a
I have to
big
explain to
enough
Victor
desk.
what a paperweight is. Victor, in the old days, before there was central air conditioning, you would open, and offices would be large and they'd be open. You would open a window and then you have a fan blowing, but all your paper would blow off your desk. And so you'd have a whole series of paperweights to hold down
gosh.
everything
Yeah.
so that it wouldn't blow away from the fan.
Exactly. Oh my
I
gosh.
know you were dying to know
So
that. Yes.
I saw you on Colbert recently, and aside from your great vest, you were adamant that Pluto is not a planet. And I don't have enough knowledge to know why it isn't a planet, or in fact, what the definition of a planet is. So could you tell all of our audience who probably are like me and don't know what a planet is and why Pluto isn't one?
Yeah. Pluto had it coming. First of all, let's get that straight. And Pluto is all right. So there are three criteria that you have to satisfy to be a full red-blooded planet. One of them is the location where you orbit. Do you dominate that space? Or are there other objects approximately your size? Because if there are, then you're something else. You're just a member of this family of objects. You don't have the singularity that a planet ought to have, given our native sense of what a planet should be. That's the first criterion. Pluto loses that criterion because we discovered beginning in the 1990s that there's no end of other dirty ice balls in the outer solar system orbiting where you find Pluto, at least one of which is bigger than Pluto. So that forced the vote. Either we make them all planets or figure out another way to think about what planets are. And so that's what we did. So that's the first criterion. Second criterion is, are you large enough for your own gravity to have shaped you into a sphere? That is true for Pluto. Pluto is a sphere. So Pluto is okay. It lost on the how crowded are you, but if it wasn't so crowded, it might be considered a planet for that reason, okay? Because it's a sphere. In the asteroid belt, all but one of those objects are craggy, chunky rocks. They look like Idaho potatoes. None of them are spheres except for one object. It's the asteroid Ceres, Ceres. Well, wait a minute. That's big enough to be a sphere, though it doesn't dominate its band. So that one doesn't dominate a sphere. It's big enough to be a sphere. That got promoted to being a dwarf planet from being just another asteroid in the asteroid belt. So we have an asteroid belt with one dwarf planet in it, and then we have the Kuiper belt with several dwarf planets in it, Pluto included. So these are the criteria.
Very interesting. So let's get into some of the images in your book. So the first one is a view from a Starman mannequin in Elon Musk's Falcon Heavy rocket launch.
I don't know if you remember when that got launched. Yeah. In
2018,
his Tesla
yeah.
Roadster. There's a mannequin
Right.
in his Roadster. Yeah.
Oh my gosh,
Yeah.
it's such an amazing view. But I'm wondering why that first image to start off your book.
Oh, because we're starting at Earth, and this is it's a human-made object near Earth, and so we're on our way out. And so it's a reminder that we will have a long way to go, but maybe we should still pause and celebrate how far we've come. And the 3D-ness of that is there were two separate frames as the spaceship with the mannequin, as the electric automobile with the mannequin in it moved, and Earth rotated. We had different views of Earth from those two facts. So you put them together, and Earth pops along with the mannequin. So we let off with that,
Yeah,
just
yeah.
to anchor the journey.
And so the next object is the moon, which is 1.3 light seconds away. And we see the moon simply as a flat, stable disk out in the night sky. But your book gives us another perspective, and you explain what happens when the moon orbits. Can you tell us more about that and what your 3D images show us?
Yeah,
terms of the
so
moon?
just to remind people how you get 3D, anything is in three dimensions if you see the object from two separated vantage points. So each one has an angle of view on the object. One eye sees it and it's in front of different objects over here, and the other eye sees it and it's in front of different objects over there. And so that is what your brain then assesses, helps your brain assess how far away the object is, because you see it in a full 3 dimensions. The farther away it is, relative to your eye separation, the less 3D it feels. And if it's really far away, your separation of your eyes is insignificant compared with the distance, so you don't see a 3D. So that's part of why distant landscapes, you don't think of them as 3D. They're just like wallpaper, okay? Only things that are much closer will convey the sense that you're in 3 dimensions. All right, so you're in these images, if we purposefully choose a frame that we know will have a corresponding frame that is a huge distance away, making up for the fact how far away it is. Like, let's use the baseline of Earth's orbit instead of just the separation of your eyes. Oh my gosh, now I can see stars as though it's an apple held in front of your hand. Stars will pop into full dimensionality. The moon, the moons of other planets. And so once we can get 2 different vantage points, the farther away they are, the more deeply 3D the object becomes. And so a lot of heavy lifting was done in the choosing and the picking and the alignment of these images so that each set of images gives you a deep 3-dimensional image, a perspective on what's in the image.
So some of the most beautiful images in your book to me were the nebulas, and I'm thinking specifically about the Ring and the Orion nebulas, which have such cool colors. How are they able to get into such an interesting formation in those colors?
Okay, so those are the remnants of dead stars. All right, so you're looking at a corpse. I don't mean to get morbid on you there, but that's precisely what they are. So the star becomes so bulbous it can't hold on to its outer layers anymore, and they just sort of escape into space. And depending on if there's winds or other sort of forces operating on it, they can take various interesting shapes. The Ring Nebula is one of the most perfect ovals that are out there. Most of them are rattier than that. But what we were able to do in those cases, because we don't have a way, Earth from one side of the orbit to the other, that's not wide enough to do anything interesting there. So instead what we did was we took images of the nebulae in different wavelengths, in a blue versus red, or green versus ultraviolet. And then you make those the stereo pictures. Those colors, as given to us by the nebulae, come from different places within the nebula. The nebula doesn't all give the same color. Green comes from here, violet comes from there, red comes from there. If you put those in 2 different images and then look at it, bam! The entire nebula takes on a whole dimensionality because your eyes are not seeing the same thing, yet your brain is putting it into one coherent image. So this was a lot of effort on this, and mostly the heavy lifting of Bob Vanderbay, because this is his baby. And all these images were chosen to be exemplar of things we talked about in the main books.
There's really nothing that can capture how amazing these images look without actually buying the book. So for our audience out there listening, please do buy the book.
Again, you're being a good commercial for me here. I should hire you.
Oh, I'd be honored. But let's talk about one last thing about the book and the images. So the images are presented in rough order of their distance from Earth, starting with the moon and then going outward from there, which made me wonder.
Starting with the space mannequin.
With the space mannequin, yes. Which made me wonder, what gives us the ability to know how far an object is from Earth?
Wow. Okay. So I'm going to have to send you to another place for that. Okay. So a couple of years ago, I co-wrote a book called Cosmic Queries, and it's a book that comes from my podcast. It's the second in a series of 3 books. Actually, we're up to 2 now, but the third one is going into press very soon. And so Cosmic Queries, it emanates from, the podcast has a very widely listened to variant called Cosmic Queries, where people ask in and they ask questions and we have fun with them. One of the questions asked and answered in that book is, how the hell do we know how far away objects are? And it is a long, complicated series of steps. You first do the parallax. Well, that gets you out to the first few hundred stars. Well, maybe you get a better telescope to measure the parallax. That gets you a few thousand stars. But now what? The stars are too far away for the Earth baseline to work as a parallax. So you have to infer other ways. So here's an object. We know how bright it is, and we think we see that object farther away, even though we can't get a parallax for it. Let's assume it's the same object and say, what distance would it have to be to look like that? And we do this with every object. And then that's a second tier in the ladder. Then how about farther out and farther out? So each tier depends on the previous tier's accuracy. If you find an error deep down, it percolates and propagates all the way up through that chain. And it's called the distance ladder. And it's described at length in the Cosmic Queries book. But now you got to buy another book. So that's the problem there.
Well, that was our first episode with you, was Cosmic Queries. So hopefully everybody who listened to that episode bought that book then.
Oh, good. Okay.
But sticking with the moon, which is, according to you, 1.3 light seconds from Earth, and is the farthest.
Well, it's according to physics. I mean, it's not that because I decree it to be
right,
so.
Yes.
It's because that's actually how long it takes.
Right. According to science.
Yes, thank you.
And so the question is, though, that's as far as any human has gone so far. The question is, do you think
technically, I mean, if you want to be technically accurate, the farthest anyone has gone has been an orbital distance above the moon's surface on the far side of the moon.
Well, man walked on the moon, so isn't that closer than an orbit?
Well, they walked
around
on the
moon?
near side of the moon. We're talking about how far away you are from Earth.
Oh, okay.
See?
Okay. All right. That's okay.
So there's a near side of the moon,
Right.
but the command module pilot orbits the moon.
Okay.
So they go around the other side, so they have the full moon diameter plus their own orbital altitude.
Okay.
So they would have been the farthest, technically loneliest person there ever was.
Wow.
The person was farthest from any other person for the longest amount of time.
So do you foresee a time when man could go a greater distance than that?
I don't see why not. Moon, Mars, and beyond. Rocket,
Okay,
baby.
so let's talk about Mars, because I think Mars is one of those places that may be of great interest to a lot of people. I know Victor wants to talk about Mars, but do you think Mars could be next?
I don't think of next. I think of capabilities. Mm-hmm. So I think, let's just turn the whole solar system in our backyard into our backyard. And if you do that, then whatever was your ambition, then you can realize it. You go into the rocket warehouse and say, I want to start a restaurant on the moon. So then you say, well, you need this rocket and this supply chain and this booster and this, and you set it together, and then you go to the moon and set up your restaurant. Or you go to Mars and look for life, or you go to a comet and extract water, or you go to an asteroid and mine the rare earth metals. You want to do all of this. I mean, why not? Rather than say, do this now and then do that next. That's very constricting of the creativity of all those who could think about the idea and come up with something innovative.
Yeah. So I took a class at UCLA called Exploring Mars last quarter and was so fascinated by it. And it's a planet that animates so many aspects of pop culture. We watched The Martian as our final exam. We had to spot all the falsehoods in The Martian, which was really fun. But tell us about maybe some of the similarities between Mars and Earth so far that we know of.
Well, Earth and Mars each had running liquid water in their past, and Earth has it in its present. So that's a good one. Mars rotates about once in 24 hours. That's a good one. Mars has a polar ice cap. Ice caps in general, that's a good one, like Earth. If we're going to live anywhere, there's no other planet. Venus is 900 degrees Fahrenheit. Nobody's living there. Now, Mars is hundreds of degrees below 0 Fahrenheit, but you can always just sort of get warm relative to that. It's much harder to get cold, all right? And so, plus at 900 degrees, you vaporize. So that's just not fun.
No.
You know, if you're a puff of smoke, it doesn't work. So those are interesting similarities. And it had, like I said, as ice caps, polar ice caps, as Earth currently does for now. And that's why we're all a big fan of Mars.
Yeah.
If there's ever a place we were going to pick next, it's Mars.
Very interesting. So on this topic of universe, this is a grim place, but I heard you talk about the universe is, continuing to expand, and this concept called the Big Rip. Can you tell us a little bit more about that?
That's scary. I don't even want to talk about it. I might have nightmares. So the fabric of space and time is currently stretching according to measurements, but that stretching, operating opposite that of gravity, is accelerating. So the rate at which the universe is getting bigger is getting bigger. And as a result, it's like, oh my gosh, what's happening to everything? What's going to go on? And it turns out there's a point where it is stretching so fast, the very threads that comprise the space-time continuum would rip because it cannot stretch anymore. And who knows what that will look like, because that'll rip everywhere, not just in one seam. Every place where you have this space-time continuum, it will rip apart. And I lose sleep over that. I don't know what that's like. And I hope it doesn't happen sooner. I hope we're getting our calculations right. And that's...
Let's all appreciate the universe while we have it.
That's a good line.
Scary.
Of course. That's right.
Is that the only thing that keeps you awake at night now?
No, I also wonder whether we are smart enough to solve our own problems. Or we just is it just, are we doomed to be terrible shepherds of our own fate? That's what I want to know. And I have to
I hope the answer is
wait
yes.
until yeah, I know, that's right. Exactly.
So, Neil, I'd love to have you read in your planetarium director voice one of the final paragraphs of your book. I don't have any questions about it, but I just want our audience to hear what I think is very compelling and thought-provoking words. So if you would not mind, please go ahead and read the last part of that.
Many of these wonders have been discovered within one human lifetime. 70 years ago, we had not yet discovered quasars, pulsars, black holes, exoplanets, the cosmic microwave background, or dark energy, which fills intergalactic space and constitutes 70% of the mass energy of the universe. The next 70 years promise to be equally interesting. We hope that in addition to giving you an in-depth view of the universe, we have imparted to you a more in-depth understanding of the exciting things still being discovered in our amazing universe.